Hi, thanks for tuning in. Let me start off by describing something that happened to me not too long ago. A friend of mine asked me to go download this really addictive app, and I did. And I soon found myself spending a lot of time using that application, setting it up just the way I like it. And then at some point, I decided to go buy a new Windows device. And one of the first things that I did as part of setting up that device was to go download that app again. And when I launched the app, I was disappointed. All of my state and all of my data that I had set up on my other device was missing when I picked it up on my new device. Now, this is a really bad user experience, but at the same time, as a developer, it's really easy for you to make a few modifications to your app and model your application data in such a way that your users have a continuous experience every time they use your application. My name is Sandeep George. Co-presenting with me is Hector Barbara. We're both program managers on the Windows Developer Platform team. Today, we're going to be talking all about application data. We're going to be finding out what are the features available in the Windows platform to help you build that continuous experience. We're going to take a look at how do you create settings on a device and sync that across all of your devices. How do you create a setting or data that is specific to a device? Now, you might have multiple users using your application on a single device. How can you share data across these multiple users? And finally, if you have multiple applications running on a device, like you have a suite of apps, how do you share data between that suite of applications? To demonstrate all of the features available to manage your application data, Hector and I decided to build a demo application. It's a very simple feed reader application. And what it does is that the user can go and configure his favorite set of feeds, all the URLs that he cares about. And when he clicks on download, it saves all of the content so that the user can go and view the content offline. So when we were building this application, we thought of a couple of things on how the user experience should be. Starting with, we created a setting. We need a setting that stores all of the user's feed URLs. And this is a setting that we want preserved on the device it's running on, and also across all of my devices where this app is running. Then we also need a setting for the number of articles that I want downloaded on a device. This is a device-specific setting. And finally, all of our content, we want to store all of our images and articles offline so that the user can go and view the contents even when the device doesn't have connectivity. First things first, what are the building blocks that are available for you as a developer to start building application data? Windows lets you create settings. Settings are a simple key-value pair. The value itself can be any of the predefined types that are shown here. And to you as a developer, it's a dictionary. And Windows does the work of preserving that setting, transporting the setting across devices. Now, you could also choose to combine two or more simple settings to form a composite setting. In our feed reader app, we have a composite setting called feed subscriptions, which is nothing but the feed name and the URL of the feed. So we are able to encapsulate two simple settings into a composite setting. All of your settings go into a container. By default, every application has an application data container, and there are containers to put your settings in. Or you could choose to create your own data container and nest that within the default container. And finally, files. These are all the file types that you care about. In our reader application, we have images. We also have text for text files. Or you could just take an object and serialize that to disk. So now that you have the basic building blocks, where do you place them? All of the constructs that you need to manage application data in the Windows platform is available in the windows.storage.application-data namespace. Now, every single application in the Windows platform has its own isolated space for data, and we call that the application data container. So using the APIs, the platform lets you get a handle to your default container by just saying application data.current. So once you have that, you get a hold of containers to put your settings in. So you have local settings and roaming settings container, or you also have folders to put your files in. So in a nutshell, every application inside its own data container has local, roaming, local cache, and temp. Depending on the storage location that you choose for your data, you can opt into different experiences for your application. Let's start off by looking at how do I create a setting and sync that across devices. Back to our reader application, we showed the feed subscription, the list of my URLs. And that is a setting that we want synced across devices. So when we create that setting, what you need to do is you specify that setting goes into your roaming settings container. Or you could also choose to put files in roaming. And when you do that, Windows syncs up all of your settings to OneDrive and then pushes that down to all of your devices running your application. Now, all of the devices need to be signed in using the same Microsoft account for this to happen. So you can put files in your roaming folder as well, and files are also propagated. The thing to note is that the roaming quota itself is quite small. It's only 100 kilobytes, and it's designed to roam small amounts of data quickly. So if you're considering maybe syncing files across devices, you could instead think of maybe just syncing the link to the files. Now, the other thing to note is that roaming is opportunistic, and Windows decides when is the best time to sync the settings across your devices. So in your application, you can register for a data change event handler. This way, if your app is running on a device, and if there's a change in roaming settings, your application is notified, and your app can react to that change. Another thing to note about roaming is that every time you install your app on a device, the platform checks if you have roaming data available on OneDrive. And if it's available, it's applied to your application during install. What this means is, going back to the pain point that I described, where when you pick up your application on a new device and all of my state was missing, the simple, easy modification that the developer could do to that app is to change the user's latest state as a roaming setting. And this way, it's available on every device and across every application install. Now, you might have data or you might have settings that are just specific to a particular device. So in our reader application, we have a setting for the number of articles that need to be downloaded per device. And the way to do that is when you create your setting, you specify that setting is part of your local settings container. Or you could also choose to put your files in local. Now, when your application runs on devices that support device backup and restore, and Windows Phone is currently the only device that does that today, all of your contents of local are backed up to OneDrive, which means if you happen to reset your phone or you buy a new phone, and as part of setting up the device, you opt to restore one of your previous device backups, all of that data that you had backed up on OneDrive for your application is restored to your application, which makes it a really nice experience for your apps. At this point, I'm going to hand it over to Hector, who's going to show us in code how easy it is to create these kind of settings.
Thank you, Sandeep, for the intro. We're going to be looking at how do we create and synchronize application data for a demo app. So as a user of our demo application, the data I care the most about is the feed subscriptions. As a user, I'm going to be adding and removing subscriptions, and it's critical that we are going to persist and synchronize those subscriptions across all my devices in order to have a great user experience. So I'm going to be adding a new feed subscription to Major Nelson's blog. So I hit add, and now I'm going to download the content. It's going to take a few seconds because it has to get online, and it has to grab all those images and articles. So let's go to the code and see how we added a subscription. Here is how we add a feed subscription. A feed subscription is a composite value that has two different items, a feed name and a feed URI. We're going to add both those values to our composite value, and then we're going to add the composite value to our feed collection. Now, we want this data to roam across all of the user's devices. And in order to do that, we're going to put them in roaming settings. And we do this here. We grab roaming settings, and we're going to define our own container inside of roaming settings, which we're going to call feed subscriptions. Then we're going to iterate through all the composite values in our collection. And using the feed URI as the key, we're going to check if this value exists in the collection or not. If it doesn't exist, then we're going to add it to our container. So the last thing I need to do in order to get all my roaming ready to go is to have a handler for my data change event. The data change event is going to allow me to react to a change in roaming data while my app is running. So in order to see roaming in action, I'm going to switch to a different computer where I have this app running, our demo app. So this is our app. This is a different computer where the app is running, and watch what happened here. We have hit a breakpoint in our data change event handler. All of our roaming data for this demo app is the feed subscriptions. So when there's a change in the roaming data, the right thing to do is to go and load our feed subscriptions from roaming and put it in our collection. And this is what we do right here with load feed subscription settings. So I'm going to go to roaming settings, and I'm going to look at my feed subscription container. And this is where having a container comes really handy, because I don't have to go through all the settings in roaming. I just go straight to my container. Next thing I'm going to do is I'm going to iterate through all the key value pairs in my roaming container. And now I'm going to convert those key value pairs to a composite value, and I'm going to add those composite values to my collection. Now I'm going to hit F5. Oops. And here you can see that the feed subscription I just added on my first computer is showing up in my second computer. The last thing I'm going to show you is how we initialize the data for our app. Here's how we initialize the data. So every time I launch my app, the first thing I'm going to do is I'm going to go to roaming settings, and I'm going to grab our container that is feed subscriptions. If it exists, I'm going to load the roaming settings into my collection. And if it doesn't exist, which could mean this is the first time the user is using this app, or maybe the user hasn't added any new subscriptions, I'm going to add a default, which is going to be the build 2015 sessions. So note that I'm not going to put this default in settings. And the reason for that is that it's a good practice to only use roaming settings for data that the user has created. So default value would be of no value to the user being in roaming settings, and that's why we are not going to put it there. Another thing I do when I initialize the app data is to go get my local setting for the number of posts to download. This is going to control when I hit download how many articles I'm going to get. And if it doesn't exist, which will mean that this is the first time the app is running, I'm going to create a default of value 5. And as you can see, using roaming is really straightforward. So with that, let's go back to Sandeep.
Okay, thank you, Hector. So far, we looked at how to create a setting and preserve that on a device and also sync that across your devices. Now, in our feed reader app, we need a way to store all of the content on the device offline. We also decided that we don't want all of that data to get backed up to OneDrive. So the perfect location to do that is local cache. The contents of local cache remain on the device throughout the lifetime of the application. Now, you might also have intermediate files, files that you don't need throughout the lifetime of your application on a device. And the location to put those files is temp. Temp is very similar to local cache, that it's also not backed up. But the key difference is that temp is volatile. And if there's a low disk space on the device, Windows can clear the contents of temp. So if you have files that you just want to use for some time, and you can put it in temp, and you can let Windows do the right thing for you. Now, switching gears a little bit, you might have a scenario where your application on a device is used across multiple users. Now, I mentioned that every application has its own data container, and that applies to users as well. So every user's data container is contained to that particular user. So going back to our reader application, we decided that if a user goes and downloads content for a particular feed URL, now if there's another user on the same machine and happens to want to read the content from the same URL, it's a nice experience to just share the data that's already available on the computer. Let me describe a more compelling scenario. Let's take an example of a classroom setting. And let's assume that there's multiple students using a shared computer. And all of the students are using the same lecture app to watch their lecture videos. So if the application chose to download and save all of the videos inside local cache or local, that data is going to be per student, which means every student on the same computer would have to get their own copy of the same set of files. Now you can see where this easily becomes a problem on devices where storage is a concern. And also, it's not the best experience because though the video is already available on the machine, every student still needs to wait and download the entire video. To make these kind of scenarios much richer, in Windows 10, we introduced shared local folder. Let me show you how it works. When a user installs an application on a machine, the application gets its user-specific local roaming, local cache, and temp folders. But the system also creates, at the machine level, a shared local folder. Now, let's consider another user that comes along on the same machine and installs the same app. So that user also gets their own application data container, but there's already an existing shared local folder. If the administrator on the machine sets a particular group policy to enable access, at this point, these applications running in different users' contexts now have access to a common share. Now, this could be really rich, and you could use it if you have sharing scenarios on your device. Now, what if you have a suite of applications and you want to share data between them? Let's take the example of our feed reader app. For all of the content that we downloaded, for all of the images, you can see that we have a like button. And what we decided is we have a second app, which is the lock screen application. When a user clicks on like, we want the users of the lock screen application to be able to enumerate all of the liked images, and then the user can choose to use that as their lock screen. So how is this possible? At this point, we're talking about two different applications which have distinct application data containers. To improve and to enhance these kind of scenarios, in Windows 10, we introduced the Publisher Shared Cache. This is how it works. Two or more applications, they have to be from the same publisher, define in their manifest that they would like to access a particular folder. And once they do that, as part of installing the applications, Windows sets up a Publisher Shared Cache, which is a folder outside of the individual application's data container, and then it enables read-write access to that folder. Let me give you an example of where this is used in Windows today. The Office suite of applications share fonts using the Publisher Shared Cache. Word downloads fonts and stores it in the Publisher Shared Cache. This way, if PowerPoint needs access to the same set of fonts, it can just use the shared copy. PowerPoint also can choose to download and add more fonts to this shared copy. This is awesome for a number of reasons, where now applications are saving space on the user's devices, and also fonts that are already downloaded by Word are instantly available for PowerPoint to use. At this point, I'm going to hand it over to Hector, who's going to show us how he took these sharing concepts and applied it to our demo applications.
Thank you, Sandeep. Now we're going to look at how do we share data between two users of the same application, and also how do you share data between apps of the same publisher. We're going to get started to how do we share data between users of the same app on the same machine. In order for this to work, we need two things. The first thing we need is to have the right group policy on the computer. So we need to enable a policy under App Package Deployment that is called Allow a Windows app to share application data between users. This policy has to be enabled in order for the scenario to work. Once this policy is ready, we need to add some code to our application. So here, in this code is where you're going to grab the content we have downloaded previously, and this is the content for our Reader app, and that content is in local cache. So we want that to be available to all the users on this machine. So we're going to be copying it from local cache to share local. So before we copy anything, we're going to make sure that local cache is ready to go, it's not null, and we check that share local is not null either. If your policy is not enabled, when you try to grab share local, you're going to get a null back. So once we are ready to go, we just iterate through all the files in local cache, and we copy them to share local. This is a very simple copy operation. And now to verify that this is actually working, I'm going to switch users on this machine. So this is a different user on the same machine, and I have my demo app running. I'm going to add the same feed description that I added for the other user. I add it, I select it, and as you can see, I didn't even have to hit download. And the reason for that is that we are using the content that is in share local. The second user doesn't have to go. They have the same feed. They don't have to grab the content. It's already on your machine. So the second scenario I want to show you is how two or more apps of the same publisher can share data on one machine. So in order to showcase that, we have created a second application that we call the Simple Lock Screen. This application is going to be taking images and it's going to be pushing them to the lock screen. And as you can see right now, there are no images available in the lock screen application. So I'm going to go back to our Reader app, and I'm going to like some of these images. So I'm going to hit like on the first three images, and then I'm going to go back to the lock screen application. I'm going to hit refresh. And as you can see, the three images I just liked are now available on a separate application. Now let's go look at the code to figure out how you can do that. The first thing you need to do for your application to be able to share data with other apps is to enable Publisher Cache folder. And the way you do that is through the apps manifest. You need to have a declaration for the Windows Publisher Cache folders extension. And inside that extension, you need to define the folder or folders you're going to be accessing. In this case, we only have one folder that we call Light Pictures. Every app that wants access to this folder needs to have the same declaration in the manifest. So in this case, our Reader app is going to have this in the manifest in order to save data to Light Pictures. And then our Lock Screen app is going to have the same declaration in order to read the pictures in Light. So then let's look at the code of how we actually play with this folder. So the key API here is get publisher cache folder. And when you call this API, you need to pass the name of the folder you want to access. In this case, it's Light Pictures. We're going to get back a storage folder, and then we're going to use the storage folder as any other storage folder. We're going to iterate through all the files in the storage folder, and then we're going to load them as images. As you can see, sharing data between applications, it's really easy with this Publisher Cache folder feature. Let's go back to Sandeep to wrap this up.
Thank you, Hector. Finally, let me close with a quick recap of all of the features that you have in the Windows platform to manage your application data. Let's look at this in context of our feed application that we built. Beginning with, if you have data or settings that need to be synced across your devices, create a roaming setting or put your files in the roaming storage folder. And Windows will take care of syncing your settings and data across your devices. If you want to create a device-specific setting or have files on a particular device, you can put that in local. On devices that support device backup and restore, the contents of local are backed up to OneDrive, and it's part of the device backup. So when a user restores his device, he gets the application with all of the data that was specific to the device. If you have data that just needs to stay on the device throughout the lifetime of the app, put that in local cache. For all of your intermediate files, put that in temp, and Windows will clear the contents of temp if space is needed on the device. And now moving on to more sharing scenarios. If you have a scenario where you have a suite of applications running on a device, and you want a way to share data between your suite of applications, you can put that in your Publisher Cache folder. And if you have a scenario where you think that multiple users of your application on a device could benefit by sharing data, put that in your shared local data. I'm hoping that this is helpful and you're able to take all of these concepts and apply it to your application to build a really awesome continuous experiences for your app. Thanks for tuning in. Bye.